You know, last day we did fountain experiment. Fountain experiment. What was the main motive of fountain experiment? It was to prove that hydrogen chloride is highly soluble in water, isn't it? So today we'll go to something else now. Yeah. So one more property which I had given you last day was if you take this hydrogen chloride, it is heavier than water, heavier than air, isn't it? So we'll prove that today. So we'll start with this experiment to prove that hydrogen chloride gas is heavier than air. We are going to prove that it is heavier than air. Okay, experiment to prove that hydrogen chloride gas is heavier than air. Now to prove this, what we do, very simple thing, the density works here. If anything is heavier, generally it moves downwards, and the lighter things, they move upward. If I look two different things with two different densities, the heavier one is at the bottom and the lighter one goes on the top, isn't it? So we'll make use of that. Yeah. So what I'm going to do, I'll take two containers. In one container, I'll take hydrogen chloride. Another container, I'm not putting anything. If I'm not putting anything, that means it is a gas which contains air. Yeah, glass which contains air. Now, what I'm going to do, look here. I'll just take this. You have a container. If it is a simple container, what will happen? This container, yes. Okay. Now you can see all the words. You can see here. Can you see all the words? Yes. Okay. Then we'll continue now. Look here. If I take this container, I'm not doing anything means it is filled with air, isn't it? I've just taken a container and that container is filled with air. I'll take another container here, and now that container will be filled with HCl. HCl is uh, heavier than air. HCl. So I've taken two containers, nothing to do. One is HCl, another one is air. So when this is taken, what I'm going to do is I'll take the first one, which was containing air, isn't it? In this at the bottom, I'll just put a few drops, a small amount of blue litmus. I'll put blue litmus there. This air container, I've already added some blue litmus. Clear? Now this blue litmus, what will happen when I take this HCl and I'll put this HCl on top of this. So this second container, I'm going to put it on top of this. So when I put the second container, here you had HCl. From here, HCl will move downwards, and this is air. Air will move upwards. Air will move upwards, and HCl will move downwards. So when this happens, what will happen? You'll see slowly at the end of the thing, this whole thing will be filled with HCl. That means this blue litmus, it turns red. It will turn red. Blue litmus turns red. So what does that mean? That means HCl which we had taken here has slowly moved and it has filled here. That means air will go here, isn't it? This container we had taken here. Any problem? Anyone? Any problem? Now you can put your speaker off if you don't have any problem. Okay, no problem, isn't it? This one understood what we are doing. This air container we have taken it here. This was the container which was filled with air and this is here. So now what will happen? HCl which was filled here slowly moves down and air will move up. So what will happen? Finally this was blue in color. It was blue litmus and finally it will turn red. So once it turns red, that means what? HCl has already reached here. So HCl is moving downwards. Means what? HCl is heavier than air. Is it clear? So these things you have to know. This experiment is there in your reduced syllabus also. Fountain experiment is also there in your reduced syllabus. Remember that. I've already seen your syllabus. Whatever is there, we'll be doing those things only. So you don't have to worry. Whatever I do, you all will be going on doing that. Okay. Now, the next thing. Uh, when I take this experiment writing part, you can do it, I think, isn't it? Or do I have to tell you how to write? This is an experiment. You'll straight away write. We are taking a jar containing air, isn't it? We are taking a small amount of litmus there, litmus solution. We are not taking dry litmus, blue litmus. This is solution. Clear? So blue litmus solution, we are taking it. On top of that, we'll put a jar which contains HCl. After some time, you'll see the blue litmus will turn red. That means HCl, which was present above, has moved downwards because it is heavier and air has moved up. So since HCl has come down, the blue litmus turns red. The blue litmus solution turns red. This is what you have to write down. Clear? Any problem? No. So all these things very clear, isn't it? Then we go to the next thing. Now look here. We had done physical properties. I gave you all the physical properties, then we proved two of them. Now we'll talk about chemical properties of HCl gas. We are taking HCl gas and then the properties, the chemical properties, we are taking this here. Okay. So when I take this, the first one is combustibility. If I take combustibility, then in this case, what will happen? We are taking a hydrogen chloride gas. In that, we'll put a burning splinter. Here, we'll just take the gas container and we'll add a burning splinter. So when I add a burning splinter, you'll see the splinter will go off. The splinter does not burn, and uh, the gas also does not burn. That means what I can do here, what I can write here, HCl gas is a non-combustible gas and does not support combustion. HCl gas is a non-combustible gas and does not support combustion. So burning splinter, you have added it to HCl gas, and that burning splinter will go off. Here, I'll just write down here in bracket a burning wooden splinter. A burning wooden splinter goes off. Is it clear? Now look here. When I take this property also I could have used here. In this experiment, I could have used the property of combustibility. What I could have done is, instead of taking blue litmus solution, I could have taken a candle here, a burning candle. So suppose here I have a burning candle. After some time, what will happen? When I put this HCl container on top, slowly HCl gas will come. HCl gas is non-combustible, and therefore the candle will be extinguished. Clear? So if the candle is extinguished, that means HCl gas has reached downwards, isn't it? So that also you could have given. Either way, you can use, you have the option, you can use blue litmus solution, or you can use burning candle. Clear? So this was combustibility. The second thing is, what about heating it? Action of heat. I'm taking HCl gas and I'm heating it. Clear? So what happens? If I take this and heat it up to 500 degrees Celsius, there will be no change at all. It is stable up to 500 degree Celsius. But when I go above 500, then the gas decomposes, dissociates, and it breaks up into hydrogen and chlorine. So here you write down HCl gas when heated above 500 degrees Celsius. Remember, below 500 nothing will happen. So when heated above 500 degrees Celsius, it dissociates into hydrogen and oxygen. It dissociates into hydrogen and oxygen. So this dissociation is because of what? Heat. So we can also call it thermal. Thermal means heat, isn't it? Dissociation. So when I say thermal dissociation, HCl when heated, it breaks up into hydrogen and chlorine. So I can write down this one, HCl. I'm heating it. What is the condition? Above 500 degrees Celsius. What will happen? It will form H2 and Cl2. H2 and Cl2. Is it clear? So this is a thermal dissociation. You know, hydrogen and chlorine, they can easily react also. So here you have written this, but at the same time it can be the other way also. That means this reaction is reversible reaction. If you go below 500 degrees Celsius, again they can combine and they can form hydrogen chloride, isn't it? Number three, action of water. I've told you on the first day only what happens when you add it to water. It is highly soluble. We have already proved also, isn't it? So when it dissolves, What happens here also? It dissociates into hydronium ion and chloride ion. So what will you write down? HCl gas is highly soluble in water. You have written this many times, isn't it? Yeah. In its aqueous solution, it dissociates. In its aqueous solution, it dissociates, producing hydronium ion and chloride ion. So it forms hydronium ion and chloride ion. So anything that forms hydronium ion, what is it called? Anything which forms hydronium ion, that solution you'll call it acidic solution, isn't it? So it forms an acidic solution. So it forms an acidic solution. So here what I can write down, HCl, this was a gas. I've added it to water. What happens? This will break up into H3O plus. H3O plus, and along with this you'll get Cl minus. H3O plus, this is called hydronium ion. You have already done this, isn't it? H3O plus is hydronium ion. Is it clear, all of you? Now, when I take this, it can react with ammonia also. What happens when it reacts with ammonia? This is a very simple reaction. Number 4, reaction with ammonia. What will happen? HCl, we are adding it to NH3. This is a gas and ammonia is also a gas. So two gases, we are mixing it up. So when I mix this, what will I get? It forms NH4Cl. NH4Cl is ammonium chloride. NH4Cl is ammonium chloride, and this ammonium chloride is a solid. Actually, ammonium chloride is a solid. So since it is a solid, what will happen? These two are gases, but this suddenly becomes a solid actually here. So when it becomes a solid, you'll see this as fumes. So you'll see dense white fumes. You'll see dense white fumes being formed. Clear? Why the fume is formed? Because ammonium chloride is a solid. It is produced by combination of two gases. So hydrogen chloride combines with ammonia to form ammonium chloride, and that ammonium chloride gives a dense white fume, isn't it? Here, one more thing you can say, that is, when I take this, that in this case, a very common question is there. That is, name two gases which combines to form a solid product. Name two gases which combines to form a solid product. So what will be your answer? The two gases, and the two gases are combining to form a solid product. Just now you have seen here only hydrogen chloride combines with ammonia, it forms ammonium chloride, that is solid, isn't it? So your answer will be hydrogen chloride gas. Don't write hydrochloric acid, it is hydrogen chloride gas and ammonia. Hydrogen chloride gas and ammonia. Hurry up, copy it. Okay, so you all have finished copying, isn't it? We'll continue now. When you are taking this, these all were properties of hydrogen chloride. We are talking about gas. Now what will we do? We'll take it as acid. So when hydrogen chloride gas is dissolved in water, then only it forms an acid, isn't it? So uh, what is called? How can we prepare hydrogen chloride? How can we convert hydrogen chloride into hydrochloric acid? We'll see that. Yeah. So the next thing, next topic you'll write down is preparation of preparation of hydrochloric acid. Preparation of hydrochloric acid. How will this be prepared? Now, when I take this, then in this case, what will happen? We are just taking uh, the same process, whatever we did In case of hydrogen chloride, we'll use the same thing, everything same. Clear? So it is same as laboratory preparation of hydrogen chloride gas, except everything is same except what? The collection part. If you take the collection part, that is different. Why? Because now we have to dissolve it in water, isn't it? Hydrogen chloride preparation is same. At the end, we'll dissolve it in water. So, except the collection. Okay. So what we were doing, I'm not drawing the entire diagram. If you see, if you remember the diagram, then in that case, what I had told you, you had the delivery tube. The delivery tube is coming from many places, and then we were putting this in a jar, and this jar, what is happening? Hydrogen chloride gas was coming down, isn't it? Hydrogen chloride gas was getting filled here, isn't it? Hydrogen chloride was being filled, air was moving upward. Air moves upward and HCl gas moves downwards. That's what we had done. What do you call it? It was upward displacement of air. But now what we have to do, we have to dissolve it in water. So since we have to dissolve it in water, we'll skip the drying part also. We don't have to dry it because finally we are going to dissolve it in water. So here what I can do, I could have just filled this with water. Suppose I fill this with water. If I fill this with water, what will happen? Whatever gas is coming, it will dissolve. You know, hydrogen chloride gas is highly soluble in water, so it will start dissolving. And when it dissolves, what you can say? If it dissolves, this solution will become hydrochloric acid. But there is a problem here. The problem is when I take this setup, the gas will come, it will dissolve, everything is well and fine, but this HCl gas is highly soluble in water. So since it is highly soluble in water, whatever gas is coming, immediately it dissolves. Immediately the gas dissolves, and since the gas dissolves, what will happen? A pressure vacuum is created here. A partial vacuum is created in this pipeline because immediately the gas will move down. A partial vacuum is created. So due to that, what will happen? This water starts filling up. The same thing happens when you are using a straw to drink your cold drinks and other things. What you do, you suck the air from the straw and the liquid moves up. So here, since a partial vacuum is created, it cannot remain vacuum due to atmospheric pressure acting on this surface. This gas, this liquid will move upward. That means this liquid starts moving in this tube. So when this moves, it can reach the reaction mixture, and therefore it may again create other problems. So this phenomenon, what happens? It is called back suction of water. Back suction of water. Clear? This is the only problem which you are facing. So what happens? Since HCl gas is highly soluble in water, a partial vacuum is created. A partial vacuum is created due to which back suction of water takes place. Isn't it? Back suction of water will take place. That means this water starts moving upward and it will reach into the other containers also. Isn't it? So you have to avoid it. So to avoid it, how can we avoid? So for that, I'll give you a simple thing here. Have you all written this? A partial vacuum is created due to which what is happening? Since atmospheric pressure is acting, this water will start moving upward, and that is called back suction of water. Due to this back suction, it may reach into the reaction mixture, so we have to avoid it. So how is it avoided? We have to see that again, isn't it? So to see that, what will we are going to do? We'll now take a different arrangement. Yeah. So I'll write down here first and then I'll show you. In order to prevent, in order to prevent back suction of water, we use a inverted funnel arrangement. What we are going to do? We are going to use a arrangement that is inverted funnel arrangement. So inverted funnel arrangement, when we are taking this, then in this case, what will happen? I'll show you the with diagram and then we'll see how it prevents. Clear? You know a funnel. Have you all copied this? We'll take a funnel. Yes. Now, look here. We are taking a funnel, and the funnel, what we are saying, it is a inverted funnel. So a funnel which should be the other way. Now we are taking the funnel in this way. You know, we have taken a inverted funnel. A funnel, we have seen it like this. You must have been to your lab. You must have seen a funnel, but this funnel is upside down, isn't it? Now what we are going to do, the delivery tube which was coming, will connect it to this inverted funnel. We can use a rubber pipe and other things, and we can connect this with the tube. That means at the end of the tube we have used a inverted funnel. Understood? Now this inverted funnel, we are placing it in a container, and in this container we'll fill water. Now when we fill water, remember, we'll always fill in such a way that it just touches the rim or the edges of the funnel. It's just touching the edges of the funnel. So here, and this one, what is it? It is a inverted funnel. What is this one? This is your delivery tube. So delivery tube is connected with the inverted funnel and kept in a container such that the edges of the funnel just touch, is just touching the surface of water, is not dipped inside. Clear? This is very important part. This is just touching. So what will happen now here? In this case, what has happened? You'll see the difference. In the previous case, there was just a pipeline. So what will happen? Here the area has increased. The surface area has increased. It's in a wider space that it is going, isn't it? And when it goes, it's not that here the vacuum is not created. Here also the vacuum is created. Clear? Now what happens? Look here. If a vacuum is created, how will it be created and what will happen? This is a funnel as usual, isn't it? What will happen here is this funnel was touching the rim of water, and since HCl gas is coming from here, due to that a partial vacuum is created. Partial vacuum means this gas will move, the gas is dissolved means here water will move up. When water moves up, what happens to this level now? Water will move up. What happens to this level? This level will move down, isn't it? As water is taken from here, the level of water will go down. Since the water level goes down, the contact between these two are lost, and since these are lost, this will again fall back. It cannot go further, so it will fall back. So what will you see? This level of water continuously, it is moving upward and downwards. Here water is filled, falls down, filled, falls down. Clear? So this keeps on continuing, and here there's enough space through which air can fill up the partial vacuum. So this moves up, water goes down, again this falls, again it moves up, again it falls down. So this way what is happening? The back suction is prevented. It's not that it is not happening, it is happening, but it cannot happen continuously. The liquid cannot go further up. It is going up, again falling down. Clear? Because this is touching, as the liquid starts moving in the funnel, this level will go down, and therefore the contact between the funnel and the water is lost. It will fall down, again the same thing will happen, and it is repeated again and again. So water moves up, falls down, moves up, falls down. Clear? So this is how we can prevent back suction of water. Main thing is what you have to know: the inverted funnel arrangement is used to prevent it. And in inverted funnel arrangement, the specific thing, the area of contact is increased, and this funnel we are just keeping on the edge, on the surface. The edge of the funnel is just touching the surface. Clear? If that is not the case, suppose I dip this, then water will again start moving upward. This process has to be repeated, then only it will prevent the water from going there. Is it clear? So all other things remain same. If laboratory preparation of hydrochloric acid is there, it is same as hydrogen chloride. The flask and other things will be same. You can see in your book the diagram is given, isn't it? So only the last part, wherever we were collecting, that collecting part is replaced by this funnel arrangement. Clear? So this funnel arrangement you have to learn it. Clear? All of you have copied? Remember the inverted funnel? Yes. The inverted funnel, it increases the area of contact. Remember that. Yeah, it's increasing the area of contact. Understood? Then have you all drawn, copied everything? Remember diagrams and all those things. Drawing the diagrams will not be asked in the examination. What is given, the diagram is given, and then you have to label it. And here in this case, I don't think this diagram will be given. If you see, the complete diagram may be given, and it may be asked why we are using a funnel arrangement. Or your question can be, how can you prevent back suction of water. Clear? And why back suction occurs? Because hydrogen chloride gas is highly soluble in water. Understood? Okay. Then we'll continue. All these things you have written, isn't it? Now the next thing which we are going to do is we have now come from the gas to the solution. So solution is called acid. So this acid, what will be the properties of this acid? Physical properties of the gas we have already done. Here we are talking about acid. Clear? So acid, also the taste, sour taste and all those things will remain the same. Clear? Mainly the differences you'll see is in chemical properties. So we'll talk about chemical properties of chemical properties of uh, hydrogen chloride, not hydrogen chloride, hydrochloric acid. Chemical properties of hydrochloric acid. Chemical properties. So here we straight away go into the properties of the acid only. It is acidic in nature. Acidic in nature, isn't it? Now since it is acidic in nature, it will have a sour taste. Clear? When you dissolve it in water, it dissociates, producing hydronium ion, isn't it? So here, if I say this one, hydrochloric acid is a strong monobasic acid. Hydrochloric acid is a strong monobasic acid. So what will happen? I've used two terms. One is strong, another one is monobasic. What does these two terms mean? You have already done acid, base, and salts, so you should be knowing, isn't it? When I say it is a strong acid, what does it mean? It completely dissociates in aqueous solution. It completely dissociates in aqueous solution. And the second thing, I have used monobasic. So monobasic acid. What does that mean? It produces only one hydronium ion. It produces only one hydronium ion per molecule in its aqueous solution. Always these properties are taken in terms of aqueous solution, you know that. So since we are talking about hydrochloric acid, it is completely dissociating in aqueous solution and it is producing only one hydronium ion. So again, we'll write down this reaction only. This is the reaction that gives acidic properties. This will dissociate into H3O plus plus. You can see this. This is your hydronium ion, and this hydronium ion is the one you're getting hydronium ion, and this hydronium ion is the one that gives acidic properties. So this is the main thing. Hydronium ion is responsible for the acidic properties. Any problem? So why it is an acid, you know it. And since it is an acid, you know it will turn color of the litmus also, isn't it? Here, if I take this, one very important thing you'll remember, if I take dry hydrochloric acid, that won't have any effect on dry litmus paper. Clear? Dry hydrochloric acid means HCl gas has no effect on dry litmus paper. Dry hydrochloric acid has no effect on dry litmus paper. Why does this happen? It is dry. Since it is dry, what will happen? Moisture is not there. Since moisture is not there, hydrochloric acid will not form hydronium ion. Hydrochloric acid is because it is dissolved in water. So here, since both of them are dry, hydronium ion is not formed, and since hydronium ion is not formed, it will not have any effect on litmus. Clear? It will have no effect on litmus. So for that, what happens? If I take this, if I want to see the effect on litmus, I have to have a moist litmus paper. Clear? So uh, HCl, suppose I take gas, turns moist. Remember, moisture is a must. Moist uh, blue litmus paper, red. It will turn moist blue litmus paper red. Understood? So dry HCl gas has no effect on dry litmus paper, but if it is a moist litmus paper, or if anyhow moisture is present, then it will turn red. So the acidic property is only when you are dissolving it in water. Suppose I take HCl, dissolve it in some other liquid. It can be in carbon tetrachloride, or I dissolve it in what is called chloroform. Then it will not behave as a acid. So acidic property only when it is dissolved in water. Understood? Any problem in all these things? No. Then let's continue with other things now. If I take other properties now, then in that case, what will happen? You know the properties of acids. The first property, A, I can say uh, hydrochloric acid. It can react now, isn't it? So hydrochloric acid reacts with bases to form. What will it form? Hydrochloric acid is reacting with bases to form. What will it form? You should be knowing by now. Hydrochloric acid. So acid is reacting with a base. So it will form salt and water, isn't it? So to form salt. Now here I'll specify the salt because our acid is specific hydrochloric acid. That salt will always be metal chloride. The salt will be metal chloride because our acid is fixed. So it forms metal chloride and water. Okay, so what I can write down, whenever I take hydrochloric acid, that is HCl, this we are writing means we are writing about hydrochloric acid. I'll add base. You know, a base. What is a base? We have already studied about bases. They can be metal oxide or metal hydroxide. It can be metal oxide or hydroxide. So hydrochloric acid reacts with the base. What will it form? Salt, and this salt is always metal chloride. Has to be here. And along with this, you'll get water. So hydrochloric acid, this is your acid, remember that. So it is reacting with the base. So acid reacts with the base, it will form salt and water. Since the acid is fixed, a salt will be metal chloride, that is also fixed. So we have done these reactions just a few days back, so I don't think there'll be any problem in this case. I can give you HCl with CaO. HCl can react with MgOH2. You know the names of all this. I've told you last day also. I had told you, or before that also I've told you. Whenever you are writing equations, you can always write the names below it, so that it'll be easier for you to revise things. Okay, so you write down these things. The names you should be knowing. HCl can react with NaOH also. HCl can react with uh, any acid, reacts with the base to form salt and water. So since hydrochloric acid will form metal chloride as a salt and water. So these things you'll try it. First you try, then I'll tell you the answers. Or you can just keep it. You can do it as your homework. Next day when we come back, we'll see these things. The second thing, since you have done all these things, I'll just give you the things, complete it, you have to complete it, and then next day we'll see what is the actual thing. I can write down this: dilute hydrochloric acid reacts with dilute hydrochloric acid reacts with active metals. I've told you which metals. The metals which are above hydrogen in the reactivity series reacts with active metals to form salt. Again the salt will be metal chloride to form salt, that is metal chloride, and hydrogen gas is evolved. So whenever acid reacts with a metal, salt and hydrogen gas is formed. So here also I'll again write down HCl. This is acid. We are adding metal, and this metal has to be above hydrogen in the activity series. What will it form? Above hydrogen in the activity series. Remember, what will it form? Salt. Salt is again metal chloride, Is it clear? So let's take some examples here also. I can take HCl, add any metal, isn't it? I can add zinc, HCl, any metal. So iron, HCl with magnesium, HCl. You can add anything. You can add sodium, potassium. The only thing is the reaction is a violent one. So all this you can complete it. HCl with zinc, HCl with iron, HCl with magnesium, and HCl with calcium. Done. We'll complete it this also. Then we'll take the third one. Dilute hydrochloric acid. Reacts with now metal carbonate and metal hydrogen carbonates. These reactions you have done it before also, so you should not have much problem here. Metal carbonate and metal hydrogen carbonates. Hydrogen carbonates are also called bicarbonates. To form, what will it form? Salt. And again I'll say the salt is metal chloride, water, and carbon dioxide. Gas is evolved. Excuse me. Carbon dioxide gas is evolved. These all are properties of acid. So whatever all acids have, this also has the same thing. What I can say here, I'm again taking HCl, and this is dilute acid. Remember, acidic properties means we are always talking about dilute acid. To this, what we are going to add? Metal carbonate or bicarbonate. So metal carbonate or bicarbonate, what will it form? Salt, that is again metal chloride. Along with this you'll get water and carbon dioxide gas is given out. This is a gas that will be given out. In the previous case, hydrogen was given out. Now carbon dioxide gas is given out. So what I can do here, you can say HCl, you can add metal carbonate or bicarbonate. So CaCO3 calcium carbonate, isn't it? HCl with KHCO3 potassium bicarbonate. This is potassium bicarbonate. HCl, I can add magnesium bicarbonate also, HCO3 twice. Clear? HCl, I can add Na2CO3, sodium carbonate. So any one of this, in all the cases, you are getting the same product. Is it clear? All of you are finished? Okay, so today we'll do up till here only. Okay, all these things you revise it. Any problem, you let me know. You can send it in the WhatsApp if you have any problem. Clear? Okay. We'll end the meeting now.